Hey everyone, so let's do a quick demo that you maybe have seen before and maybe you haven't. But we're going to talk about the differences between 8-bit and 16-bit. 32-bit is a discussion for another video, but we're going to talk about compare and contrast 8-bit versus 16-bit. Just again, as a demo, because a lot of people don't realize entirely what it means. First and foremost, if you're working 8-bit and you open up a shot and you do skin editing, let's say it's a portrait or some general cleanup and healing and this and that and everything else, and then you do a little bit of a color grade and export, like 99.9% of the time, you're going to be fine. Okay. But why do we care about 16-bit, which is not just a little bit more data, it's a lot more data than 8-bit. Why do we care? Well, it depends on how much heavy lifting you're going to do and how much flexibility you want, not unlike raw. So let me show you an example. Okay. So I have a couple of actions here, which yet again, another video will explain sort of the technical aspect, but we're going to make a couple of things. Okay. We're going to make a Granger chart, but I have them into a circular format just because they look cool on squares here. So we're going to make a quick Granger chart. Okay. And we're going to make it here on this one as well. What are these two files? Well, this one is 16-bit, just a blank document. This one is 8-bit. So I have the action set up to create this Granger chart both ways. Okay. Or rather just on, just set it up on wherever you are. It creates this chart. This is 8-bit. This is 16. They look identical. Okay. If you zoom in, these are 4,000 pixels wide, especially on the video here on YouTube, you won't be able to see the difference. They are basically identical. Okay. And I'm going to zoom in just for my own benefit. A little bit of banding here on the 8-bit, very small. But see, this is where you can't hide. When you have a photo, you kind of hide your crimes of 8-bit or hide your crimes of other modifications. 8-bit and 16-bit are hard to tell on a busy photo. But when you have this, just literally pure hue and luminosity and saturation, it tends to show the weaknesses of a bit depth. But that's not even the demo I want to show you yet. So what I'm going to do now is a process where it uses the, again, this is for another video, but it uses HSB, HSL. And what we're going to do is we're going to maximize the saturation to 100, and we're going to maximize the brightness to 100 on both of the images. We're going to leave the hue angle where they are. Now, what we should see when we end up with it is a sort of a radial angle sort of spectrum, because that's how these were created. What I did was they start with well, let me just do it. Okay. So we're going to go ahead and choose this maximum SB. That's the action that does it. This is a 16-bit, right? Boom. This is how that circular Granger chart thing started, just like this. And then I added another one on top to create the blend using luminosity from white to black to create the different luminosity ranges. Now I can, that data was in there. The data was in that image. So when I did this extraction, removing, or rather maximizing the S and the B, saturation and brightness, it brought it back to normal. So I processed the data, the pixels, and then I processed them again to go back to where it started, and it's clean. It's clean. Now, what happens if we go to 8-bit? Let's see what happens on 8-bit. We're going to run maximum SB. It's not so clean, is it? You see that? We start really seeing the weaknesses at the perimeters, at the edges. Let's zoom in a little bit so you can see. See all this messed up data? All this sort of chunking and mess up? For the most part, you won't really see that. Okay, you might ask why this is red and blue so strong right here. That's, again, a discussion for another time. But it's pretty clear. You don't need to be color science nerd to see the difference. So why does that matter? Well, this is the most extreme case. You're going to start with something, a beautiful rainbow, circular rainbow, and then you're going to modify it to add luminosity elements to it. And then you're going to extract the luminosity elements out of it using another process. What happens? Well, the data breaks down because there's not enough data. In 16-bit, you have tons of data in there and you can do it. And you can keep the process going. And eventually, if you keep cycling through the process, you'll start seeing some degradation. 8-bit, you see degradation immediately. So it's not the most useful piece of information if you're just trying to make pretty pictures. But at the same time, knowing this is important when you get a little bit more technical, especially on creating color selections, or if you're, a retouching technician in a retouching firm or in your own company, etc. So I want to show you guys the difference between 8 and 16-bit. This is an example that I haven't quite seen done exactly like this, so I want to show you guys today.